As you can see over here, a lot of numbers, expressions just flying in. I'm calling this session as Multiverse of Multiplication. Of course, it's inspired from Multiverse of Madness. iQuanta presents a session by me. My name is Abhishek Leela Pandey. I am an author, a speaker, educator, and a mathematician. Today I'll be discussing some techniques, tips, and tricks so that you can multiply really quick. Today we'll be focusing only on multiplication, various ways to multiply things. So welcome everyone. Good evening everyone once again. Let's start the session. Today we will be doing a technique called base multiplication. And here we will be using various ancient techniques as well as modern techniques. I'll also be using Vedic mathematics, a system called Trachtenberg System of mathematics was developed in Germany. And so Germany, India, and apart from this, some Chinese techniques as well, some Japanese techniques. We'll be doing a lot of things over here, a lot of fun over here. And this would be applicable to all sorts of people who are preparing for any kind of aptitude exam, be it CAT, be it GMAT, be it CUET, banking, SSC. It's applicable to everyone and applicable to everything which comes under aptitude. So base multiplication, let's start with it. The first thing that we'll be doing over here is base 100. All right. So here we'll be discussing the multiplication of numbers which are a bit greater than 100. Like two numbers are there, n1 and n2, and they are greater than 100. And here there's one thing which is the prerequisite of this class. It's that I am assuming that you guys know the multiplication tables from 1 to 20. The numbers which are very close to 100, we'll be doing it by this way. Which are not close, we'll be doing by some other way. So let's start with the numbers which are close to 100. Well, let the two numbers be 102 and 108. How do we multiply this? So conventionally speaking, you do it by this way. You'll multiply by 8, then 0, then 1, and then add up everything. But here we'll be doing something really exciting, some cool stuff. The base of these two numbers is 100. All right? And how much more is 102 than 100? It's 2 more. So I'll write plus 2 in the right-hand side, and similarly, plus 8 in the right-hand side. Now, once I have done this, I'll be adding 8 to 102 or 2 to 108. It's the same thing. If you check it out, it's the same thing. 102 plus 8 or 108 plus 2 will be same. So it will always be same. That comes out to be 110. I'll write this over here, and then I'll multiply 2 and 8. 2 multiplied by 8 is 16. I'll write 16 over here, and that's all. The number is multiplied. This is the product. Is this exciting? You can do it mentally. Once you start doing it, practicing it, you can do all these things mentally. 11016 is the answer. That's all. Now let us check out some other numbers. For example, 103 and 102. Now this number is 3 more. This is 2 more. The similar way, I'll just add. I'll get 105. And then 3 2s are 6. There's one thing which has to be kept in mind, that here 2 8s are 16 was a 2-digit number. It's a 2-digit number. And here 6, 3 2s are 6 is a single-digit number. But I require 2 digits. So you have to always remember that the product should be of 2 digits. And if it is of a single digit, I'll just put a 0 over here and write 6. So 06, just to make it a 2-digit number. So this becomes 10506. All right. Now, what if the number is of 3 digits? For example, if I take 112 multiplied by 113, this one is 12 more, this one is 13 more. Now here you will have to pay attention because some people, even after going through this technique, they start taking +2 and +3 over. This is a very common mistake. I have seen a lot of people are doing that. But the base is 100 and we should be taking it +12 and +13. Now if I add 112 to 13 or 12 to 113, I'll get 125 in both the cases. Then 12 multiplied by 13 is 156. 12 multiplied by 13 is 156. Now you will be asking, how do I multiply this quickly? How do I know 12 and 13 is 156? We'll go to that as well. But first of all, so let us consider, so 12 13s are 156. The problem over here is only 2 digits are allowed. Only 2 digits are allowed. So I'll retain the last 2, and this one I'll send as a carryover. So 125 and 1 goes there, becomes 126. And here we have 5, 6, and this is the answer. So the method is same. Only thing we have to keep in mind is that only 2 digits allowed. If 1 digit is there, we'll put a 0. If 3 are there, we'll just carry forward the leftmost towards this sum. So that is how we can do it. Bhavna, this is applicable to all the exams in which you use mathematics or aptitude. So it is applicable to everything. Okay, so far so good. Now let us try out a few numbers. Let's see how many of you understood this. Now tell me the answer of 108 multiplied by 112. Yes, come on. Shoot the answers in the question, in the comments. Pankhuri, just hold your horses. We'll go to that as well. First of all, we are checking the numbers which are close to 100. All right? The 172, 182 would be close to 200. We'll go over there as well. Just wait. First of all, let's do this. War God. Okay, everyone, the thing which I am telling over here, let's pay attention to this first. We'll go to all kind of variations. Don't worry about that. So here, if we do it, this one is 8 more, this one is 12 more. Now if I add, I get 120, and 12 8s are 96. So all of you have found the correct answer. Very good. Nice. Well done. Now going to next variation in which the numbers will be less than 100. So I'm using 2 numbers. In the first case, I used 2 numbers which were more than 100. Now I'll be using 2 numbers which will be less than 100. So let us assume numbers like 95 and 98. As we did in the previous case, the number was more than 100. We wrote the difference over here. Here also do the same thing. So 95 is how much less than 100? It's 5 less than 100. I'll write -5 over here. And 98 is 2 less than 100. I'll write -2 over here. Once we have done this, 95 minus 2 or 98 minus 5, I'll get 93 in both the cases. All right? Then 5 minus 5 multiplied by -2 will be equal to 10. So we'll get 9310. So I think this is clear to everyone. It's very easy. Now I'll just give you a problem and you will try to tell me the answer of it. What if I want to multiply 97 and 99? Yeah, Pankhuri, this video will be uploaded on YouTube. Of course, it will be there. Tell me the answer to this problem. 97 multiplied by 99. (97) is 3 less, 99 is 1 less. We get 96 over here. And 1 3s are 3, it's a single digit number. we'll have to put a 0 and we get 03. So the answer is 9603. अभिमन्यु अप्लाई करना याद नहीं रहा, अब याद रहेगा आपको. अभी हम इसको और इंटेंसिटी बढ़ा देंगे. Okay, let us take 88 multiplied by 85. Tell me the answer over here. This is minus 12 and this is minus 15. $7480 will be our answer over here. Very good. So people have, okay, all of you have done it correctly. Well done. Now going to next variation. Now the things would become difficult, a bit difficult. Now we'll select two numbers in which one will be more than 100 and other will be less than 100. For example, 105 multiplied by 92. As someone asked in a comment that how to do these numbers, one is more than 100, other is less than 100. So in this case, like 105 is 5 more than 100, I'll write plus 5, and here I'll write minus 8. So far, so good. Now, we can either subtract 8 from 105 or we can add 5 to 92. In both the cases, I'll get 97. This is something which will always be there. All right? Now comes the real problem. If I multiply plus 5 and minus 8, I get minus 40. And we cannot have a minus 40 in between the number. So what we'll do over here, here we have two blank spaces, and that is why we're able to put any two numbers in these spaces. When the spaces are vacant, in mathematics, those spaces are essentially filled by two zeros. All right? Now we'll have to subtract 40 from this 9700, and we'll get 9660. All right? This thing is clear. This can be done in one more way. So when you got 97, two spaces are vacant, which has to be filled by minus 40. 40 is how much less than 100? It's 60 less. Just write 60 over here and subtract this number by 1. You'll get 96. This is basically the borrowing which you might have done back in standard second or third, borrowing from the leftmost digits. So we get 9660 over here. So I think this part is clear. When one number is greater, other is smaller. Okay, so I think all are getting the correct answer. Aman has got the wrong answer. Aman, please check it once. Okay, Aman, you have done it. Very good. Cool. Well done. Now let me take a number like this. 85 multiplied by 112. Here you will get a 3-digit product, and it can be a bit difficult. 85 multiplied by 112. Let's do this. Are you guys excited and happy about these things? And you might be observing that we are increasing the level of difficulty and intensity after every example. So towards the end of the session, we'll be doing something really cool. Well, what can be the answer over here? So the first thing, which is very common, we'll get 97. Now we have minus 15 multiplied by plus 12, we'll get minus 180. All right? So exactly. As I said, we have two zeros over here. We'll just subtract 180 from here and we'll get 9520. So this method has to be kept in mind that the last two positions Last two positions were vacant, and any vacancy in mathematics is represented by the number called 0. So that is how it works. Swati, welcome to the class. Great. Everybody has got the answers 9520. Bhavna, do it again. Very good, very good. Now going to the next variation of the same kind of base multiplication problems. Numbers which are greater than 200. So someone mentioned that how to multiply numbers like 188 and 170 something. So I think now the person has got the clarity that that will be covered under when numbers are less than 200. So we'll cover that in this case. First of all, let's cover the numbers which are more than 200. For example, 203 and 205. Everything is same. There's just one minor difference. Okay, it is same. 203 plus 5 or 205 plus 3, you will get 208 in both the cases. This is not the end. There's one more thing which you have to do over here, and that is you have to multiply this by 2. All right? That is the only difference. So when the base is 200, after adding this up, we need to multiply this by 2. Only this part. Not this. Here we'll get 3 5 is 15. We'll leave 15 like this. We'll multiply 2 with the sum, and we'll leave 15 like this. So here we get 41615. This is our answer. Swati, I cannot repeat everything because that will be, again, wasting of time. But after session is over, you can watch the recording again. It will be available as a recording. So just try to understand the things which we are doing right now. 41615. So I think this is clear. So the only difference is we multiply this by 2. Now tell me, if the numbers were in the base 300, what would you have done? For example, if it was 308 multiplied by 307, in this case, what would have been your answer? Well, I'm waiting for this. What should we do over here? Just tell me in the comments. We need to multiply this by 3, and that's all. 94556 will be our answer over here. Very good, Ayan. Ronit, Janvi, Rajneesh. Perfect, perfect. Dikshesh, your guess is absolutely correct. Well done. Okay, so that means if the base is 700, we'll multiply by 7. If the base is 100 times n, any multiple of 100, we'll multiply it by n. That's it. That's the end of this rule. Now let us take some examples. Next, I would like to do something which is less than 200. This is 2. Okay. So let us take numbers like 182 multiplied by 191. This is 18 less than 200. This is 9 less than 200. So whenever you get the numbers, you'll have to identify how this process works. First of all, you'll have to identify the base. And once you have done that, you'll just put in the thing which I just told you. Abhimanyu, yeah, we'll do that as well. We'll do base 50 as well. Let's solve this one. Bhavna, you got 944. That was the previous answer. This one. Here we get 346. Here we have 162. And this one is extra. This has to be carried forward because only 2 digits are allowed in the end. So carry forward, you'll get 34762. Hardeep, you got 38. Abhimanyu, check it out once. Why did you get 38 over there. I think you subtracted. Here both the differences are negative. So negative multiplied by negative is positive. We'll subtract only if one is positive, other is negative. Okay. Well done. Now I will check for when one number is more than 200, other is less than 200. For example, 208 multiplied by 193. Tell me the answer over here. Shiva, you have a doubt. Shiva, basically, whatever you get as a sum, you multiply that by 2. And whatever you get as the product, if it is 3 digits, we will just transfer the leftmost to the left digits. Akash, we can do that as well, but the problem over here is that we don't know the multiplication of 82 and 91. For that, we'll have to, spend more time. So it's better that we choose the lowest possible differences. All right? We can do by that as well. We'll get the same answer. Why we are doing this? Because we need the low numbers, smaller numbers, so that we can multiply them quickly. Okay, now we can do this, we'll get, I'm so sorry. 208 minus 7 or 193 plus 8. That's what we have to do over here. We'll get 201. We can multiply this by 2. And this one will be, it's minus 56. That is minus 56. We have 2 zeros over here. So we'll get 402, 00 minus 56. Okay, so if we do this, we'll get 40144. This is what our answer will be. Perfect. So everybody has done the same thing? Well done. Great. As we discussed, any multiple of 100. So let us give me a few numbers to multiply. What about 808 multiplied by 806? Tell me the answer, quick. Here the base is 800, all right? This is 8 more than 800, this is 6 more than 800. Now if I add 808 to 6, I'll get 814. And I'll have to multiply this with 8 because the base is 800. And 8 6 are, we get 48 over here. Let us do this. Six, 5, 1, 2, 4, 8. Is this what you have got? 6, 5, 1, 2, 4, 8. Very good. Well done. Perfect. So that means all the people who are watching this session, now they are comfortable with this kind of multiplication where the numbers from same bases are involved. Now we'll go on to the next variation of the same kind of problem in which we'll be doing base 10. Base 10. So for example, we have to multiply 12 and 13. Now, before doing this, I want to tell you a story. So this might have happened with all of you. So when we were young kids, at that time, like my mom, she asked me to, kind of cram all the tables from 1 to 20. But I could not. So it happened with table of 12. Somehow I did it. So basically what I did, and I think all of you must have done it, that you start writing the table like this. 12 multiplied by 1 is 12. This is a very interesting story. Pay attention and try to have a memory recall if you have done the same thing. 12 into 1, 12 2s are 24, 12 3s are 36. So all of us did this thing. Now thing is, once we did till 120, 12 multiplied by 10, we stopped over there. And that is the problem. We could not develop the logic which was required and we tried to mug up everything which came to us. So at that time, just because I was playing with the numbers, I tried to go beyond 10. And that is where the real enlightenment came. I'm sharing this with you and tell me if you have done the same thing. So I tried to write, by normal multiplication, I did it. I wrote 132. Then I did 12 into 12. I got 144. I was the same way all the kids were doing. But once I did this, I kind of found a pattern. The pattern was that here we have 13, 14, 15. Here we have 2, 4, 6. So now tell me, without calculating, if you can see this pattern, this is in ascending order, right? This is very exciting stuff. 13, 14, 15. Here you 2, 4, 6. So what could have been the answer of 12 into 14? So by this pattern, I got the answer as 16, and here I got 8. And then I tried to verify it by normal multiplication, and I got 168 as the answer. Right. So this might be the case with a lot of people who are over here. So what I want to tell over here that we need to push our boundaries. Even multiplication tables, someone who pushes the boundaries is able to do everything. So pushing the boundary of the normal established notions of multiplication tables, I tried to find something, and this is how I came to know some very interesting property of numbers. And this was so good, right? In table in of 5. All right. So after that, 12 into 15, when I tried to do, there came the main problem. Okay, we have 18 over here. Here we have 10. Now it is not possible. Then I tried to verify it by normal calculation. I got 190. Then I understood that this thing has to be carried forward. All right, so this is something which was common to a lot of people who were playing with numbers. Afterwards, when I came across the Vedic mathematics and everything, then I realized that these things have been done by our ancient Indian mathematicians. All right, so now let us come back to what we were doing. Anybody among you who has done this? I really like talking to people who play with numbers. Okay. So here, the same way as in base 100, the base over here is 10, write 2 over here, write 3 over here. Just add 12 to 3 or 13 to 2, you get 15. And here is 2 3s are 6. And here we require only one digit. Like in the case of 100, we require 2 digits. Here we require only one digit. And the reason is very simple. All right. This is 17, so this will be 180, not 18. Okay, so here we require only one digit. All right, is this thing clear? Yeah, it's 17, Tulsi, I got it. 16, 17. So this thing is, I suppose, clear. Now let us try to play with more numbers like this. If the numbers are, okay, check one more number. Let us take 13 multiplied by 17. Let's try to find out the answer over here. Naira, you found a table of 16. Yeah, right. Table of 9. Okay, very good. Base 100, 200 as well. And yeah, same concept is there. Very good. So I think now you guys are trying to relate things with when the base is 10, the base is 100 and so on. Very good. So here we have plus 3, here we have plus 7. Just add it up, you get 20. 3 sevens are 21, only one digit is allowed. 2 will be carried forward, and that is how we get 221. Well done, everyone. Akash played with numbers in 12. First time you got 43 of 80, and then second you got 3 out of 80. Akash has got a sense of humor. Okay. Now, what are the numbers are less than 10? Of course, we can do that. 7, 9, 63. We remember all things, but just for sake of the pattern observation, let us try to do 7 into 8. All of us know the answer is 56, just for sake of pattern observation. So this one is 3 less than 10. This one is 2 less than 10. 7 minus 2 or 8 minus 3 is 5. And this comes out to be 3 2s are 6. See, how cool is this? So multiplication has this kind of property. You always get patterns. And this pattern, when extended, can also be used to find the squares of numbers. Right? So let us do this. Now we'll try to find the squares of 2-digit numbers. Ready for that? All right. So now if someone asks you, what is the square of 11? So in your mind, you can just write it like this. And then you can find out this is 12 and 1 ones are 1. This thing can be used for all the numbers, for finding the squares of the numbers. For example, I need to find the square of 103. Okay, square of 11 is known by everyone. 103. How can you do this? So just make a map in your mind. 103 multiplied by 103. If you try to do this, you will get plus 3 in both the cases. Just add them up. And 3 3s are 9. We need 2 digits. So put a 0 before here. And you get 10609. Right? Bhavna enjoying the maths lecture? Okay, Bhavna. So we get 10609. Now I will want you to answer the few squares which I'm writing over here. Tell me the answer to 107. Be quick. कॉमर्स को कुछ फ्लेक्स करने को मिल गया. Shivangi, it's 10609. You need to put a 0 before it because now the base is 100. We require 2 digits in the end. 107 square. What is the answer? 11449. Abhijit said that. Very good. Abhimanyu, Roned, Hardeep, Aditya, Ishan, Ashish. Well done. Well done. So here we'll get 11449. Okay, now I think you guys would have found another pattern over here as well. It's the same thing. What is happening? Let us understand it in terms of algebra. Can I say I can write 100 plus x over here and 100 plus x over here? Is that fine? Let me change the slide. There are two numbers, 100 plus x. I have to find the square, and 100 plus x. The difference I can write here, x and x. All right? If I add this to this or this to this, I get 100 plus x, or I can say 100 plus 2x. And here I get x square, which is of 2 digits. Now, what I have done, I have actually made a generalized formula for this. Akash, अगर सिंगल डिजिट आएगा 0 लगाएंगे, अदरवाइज छोड़ देंगे क्योंकि 2 डिजिट्स हमें चाहिए होंगे. So is this thing clear? Now we can find square of any number which is close to 100. For example, if you want to find the square of 108, what will you do over here? 100 plus 2 times x. X is 8. So 100 plus 16 is 116. And square of 8 is 64. That's all. You got the answer. Right? Is this part clear? Is this clear, guys? Okay, one more. 106 square. Tell me the answer. Quickly. (106). What will be the answer? 11236, isn't it? All right. All right. 11236. Ashish, just check your answer. You just typed 2 by mistake, I think. 11236. Very well. Okay, can we apply the same thing when base is 200? Is that possible? What if I ask you square of 203? In this case, what will you have to do? You will have to basically multiply this part by 2, right? So let's try to do this. 203 square. This will be 200 plus 2 times 3, that is 206, multiplied by 2, and we get 09 over here. Because 3 square is 9, it's a single digit. We require 2 digits, we put a 0 before that. And that is how we can we can find the answer to square of 203 as well. 41209. Very good. Perfect. So now, are you guys feeling smart that you are finding the squares of numbers more than 100? Yeah, of course, there's a limit to it. But do you think you are at least 10% smarter than you were before this class? See how beautiful mathematics is. 4120. I'm so happy that all of you are getting the same correct answer. Let us play with numbers more. Okay, what if I want to find the square of 707? Tell me the answers. Atul, 203 again. Okay, I'll do with 707. You'll get the answer. I think the comments are reaching me 2 seconds later. There's a lag. But I'll do it with 707 and you will be able to do that. घर में बोल सकता हूँ कि मैथ्स आती है. Right. 707 square. What is the answer? Abhijit says 499849. Okay. दीदी को ताकि फ्लेक्स करूंगा. Okay, okay, very good. 499849 is the correct answer. Well done, guys. So this can be done is 700 plus 2 times 7, that is 14. All right, then multiply by 7 over here. Base is 7 and then 7 square. So I get 49 over here. 714 multiplied by 7 is 4998 and this is our answer. So look at this, the 6-digit number. You have found the 6-digit square just in, a few seconds, I believe. Okay, let us do a difficult one. Square of the number of God, 786. 786 square. How to find that? Now tell me what will be the base of this? The base of 786 will be what? Manu, there is no limit. The more you practice, because I'll be taking one more session of this, I will give you some time, some breather so that you can practice this, and after that, it can be unlimited. The base will be 800. Aditya, very good. Right, Dikshesh? Yes. So base is 800. Okay, this is how much less than 800? This is how much less than 800? This is 14 less than 800. Right? Abhijit has got the answer. Very good, Abhijit. Abhimanyu as well. 617796 is the correct answer. Well done. Very good. Very good. Great. So we'll just subtract 14 two times from this and then multiply this by 8, and here we have 14 square. So if you solve it, you'll get 617796. That is the correct answer. Very good. Well done. Now coming to next variation. Okay, I just want to ask you something. We did this, the base 10. So if the base was 20, for example, 21, 23, what will you do over here? It's very similar to 200. In my family, only I hate maths. Now I can flex. Good, Nandini. Ronit, you did it wrong. Okay, cool. No worries. 21 and 23. It's very similar to the base 200. So whatever we do for base 10, we just need to multiply this part by 2. That's it. Plus 1 and plus 3. Just add them up. You get 24. And multiply this thing by 2. And that's all. Your life is easy. Right? So you'll get 483. Very good. Well, so I think base multiplication is clear to everyone. And if you kind of practice 10 numbers every day for next 3 to 4 days, you will be through it. And the best part will be if you teach this to someone, your sibling or anyone, and your friends, that will be able to help them as well as you. They will learn something new, and once you teach something, you'll always remember it. You'll never forget that. So teaching is the best way of learning, okay? So how many of you are going to do this after the session is over? Go back to your homes. If you are there, it's good. Talk to your parents, friends, siblings, and try to teach them these techniques. And of course, you can flex. Now comes the next variant when bases are different. When the bases are different, like one can be in base 100, other can be base 200. What then? Here comes a technique from Germany that is called as Trachtenberg System of mathematics. And this will also be very easy, a bit difficult than the previous case, but not very difficult. So look at this. This is called as Trachtenberg Triangle. If you look at this, 1 multiplied by 1 is 1. 11 multiplied by 11 is 1 to 1. So the number of digits, here we have 1, 2, 3 digits, right? So the square will be 1, 2, 3. We'll write in ascending order 1, 2, 3, and then in descending order 2, 1. So we'll get 1, 2, 3, 2, 1. All right. Similarly, if there are 4 digits, 4 times 1, 1, 1, 1, 1 square, right? 1, 2, 3, 4, ascending order, then descending. 3, this is not there. 3, 2, 1. All right. 1, 2, 3, 4, 3, 2, 1. So this part is clear. Now we'll use the same thing for multiplying numbers from different bases. How to do that? Ronit Trachtenberg. Okay, I will just write the spelling over here. During Second World War, Jason Trachtenberg developed a number developed a method to multiply numbers, and that is called as Trachtenberg system. Yeah, Bhavna, yeah, it's basically the squares, but this will use for multiplying different numbers. Now, I want you to I want you to focus on visualization of this. This is one. I'll just make a symbol, a vertical straight line for 1. For 1 to 1, one vertical straight line. For 2, a cross. For 1, again, a vertical straight line. Pay attention to this. Now it's 1 to 3 to 1. One vertical line for 1, a cross for 2. For 3, a cross and a vertical line. So basically, whatever we have to make, we'll make by crosses and vertical lines. If there are odd number of elements, a vertical line will be required. Even number of elements, a cross will be sufficient. Now, for 2, again a cross. For 1, a vertical straight line. I hope this is clear. Is this? Now coming to the 4, this one. For 1, a vertical line. For 2, a cross. For 3, again the cross and in between a vertical line. All right. For 4, it's an even number. 2 crosses. No vertical lines. For 3, again a cross and a vertical line. For 2, this, and for 1, this. I hope this part is clear. We'll take it up one by one. We'll take it up one by one. If it's a bounce, we'll take it one by one. We'll take these 3 first, then we will take this. Okay? So for a while, ignore this one. Let's solve these 2. Okay, let's solve this first. All right. So I'm changing the slide, and now I have to use this. So if numbers are 1 digit, for example, I want to multiply 3 and 7. It's very easy. So this symbol is basically the flow of multiplication. All right. So to the people is not clear. It'll be clear once we take the examples. So this vertical straight line represents the flow of multiplication. 3 sevens are 21. Okay, all right. So far, so good. Nothing new. What if the numbers are 2 digits? For example, 23 and 45. Now, one number is in base 20. The other one is in base 40. What now? For 2 digits multiplication, the symbols were this. This part is clear? A vertical line, one vertical line, a cross, and a vertical line. We always start multiplication from right hand side. So right hand side there are, as you can see, there is one vertical line. Right hand side will multiply vertically. Which part? 3 and 5. This 3 and this 5. We get 15. Just write 15. Put an underline to it. All right. For this cross, 2 5s are 10, 4 3s are 12. 2 5s are 10, 4 3s are 12. 10 plus 12, we get 22. Just write that, put an underline. And this one from the leftmost, 2 4s are 8. Once we have done this, now any place, any vacant position would allow 1 digit only. So 5 will be retained and 1 will be carried forward. All right. So this becomes 23. 3 will be retained, 2 will be carried forward. That becomes 8 plus 2 is 10. We have 1035 as the answer over here. Is that clear, everyone? Ronit, Ayush, and Shivangi have already solved it. Others, is this clear? We'll take some more examples. All right. Let us take a few more examples. One more example. 21 multiplied by 67. The symbol is this. 1 sevens are 7. 2 sevens are 14. 1 6 are 6. We get 20 over here. 2 sevens are 14, plus 1 into 6. Similarly, 2 6 are 12. 7, 0, 2 goes forward, we get 14. So whenever we have a single digit, we'll keep it like that. If we have two digits, we will transfer the leftmost digit to the left spaces. So this will be our answer. Good. So people have got it. It's not a bouncer anymore. Now we can move on to 4 digits. For 4 digits, I'll just repeat the symbology all over again. 1, 2, 3, 4, 3, 2, and 1. Okay, let us solve it. 2, 1, 3, 5 multiplied by 4, 6, 7, 2. I'll just, okay, the symbols. Now you have to pay attention to this one because this can confuse. From the rightmost one, a vertical line. 5 multiplied by 2. I get 10 over here. I'll just write 10. So far, so good. Then these two. 3 2s are 6. 7 5s are 35. I get 41 over here. Then these three. 1 2s are 2. 6 5s are 30. 3 7s are 21. So 2 plus 30 plus 21 will be 53. Is that clear? I'll resume once you tell me that this is clear. So I will resume this. Is this thing clear? Yeah, I'm waiting for the comments. This is clear. Okay. Good. Now 4. This 2 and this 2. 2 2s are 4. This 4 and 5. 1 and 7. 3 and 6. So if you look at the symbology, I'll use different color. These two and these two. This is how it works. Third part, okay, this one, okay. The right 3. 1, 3, 5, we had 1, 3, 5, and we have 6, 7, 2 over here. So 1, 2s are 2, 5, 6 are 30, 3, 7s are 21. 2 plus 30 plus 21 is 53. That's how we did it, okay? Similarly, for the 4, this 2 and this 2. 2 2s are 4, 5 4s are 20, 1 7s are 7, and 3 6s are 18. So we get 4 plus 20, 24, plus 7, 31, plus 18, 49. All right? Okay. The 3 symbol, now this one, from the leftmost. 2, 1, 3, and 4, 6, 7. 2, 1, 3, 4, 6, and 7. We'll do it like this. Janvi, Sarah, is this clear now? 14 plus 12 is 26, plus 6 is 32. 2 7s are 14, 3 4s are 12, 1 6 are 6. 32. Now, the left 2 digits. 2, 1, 4, 6. 12 plus 4 is 16. Leftmost 2 and 4 is 8. This is what we get. Okay. Okay. Abhimanyu, you are right. Abhimanyu, देखो, 4-digit multiplication, even if you leave this part, it's okay. You won't be getting such huge numbers, but I'm showing this to you just for the sake of making you understand the pattern. That's it. Till 3, if it is clear, it's good to go. Just for the, just for making you believe that mathematics is so simple, so beautiful, that the same pattern can be applied across all the numbers. So 0 is retained, 1 is carried forward, we get 42. 2 is retained, 4 goes there, 4 plus 53, 57, 5 goes here, 5 plus 49, 54. Again 5 goes here, 37, 3 goes here, 19, 1 goes here, 9. So All right. Okay. Now, I'm repeating one thing. If 4 digits is not cool with you, it's okay, no problem. But it's very easy. And as Vishal said that you want me to repeat the 49 wala, this one. The numbers were 2, 1, 3, 5, 4, 6, 7, and 2. So look at this. 2 multiplied by 2, 4 multiplied by 5, 1 multiplied by 7, 6 multiplied by 3. That is what we did. Clear हो गया? Time लग रहा है, कोई problem नहीं है. Let's do one thing. You guys practice till 3 digit, leave 4 digit the way it is. If 4 digit somehow comes in DI questions, you just can use calculator. But I'm sure if you move till 3 digits, automatically your mind would be wanting more. It happens. Reward mechanism. छोटा काम करो, फिर मन करता थोड़ा सा और बड़ा करें. So that is how it goes. But it's all right. ठीक है? Addition. 2 2s are 4. 2 2s are 4. Plus 4 5s are 20. Plus 1 7s are 7. Plus 3 6s are 18. That's it. Cool. Okay, Karthik here knew this method but confusing when apply like 3. Okay, we'll do that as well. And that will be, yeah. Okay. For example, okay, just do one thing. 4 digit can be done via calculator, but just for the symbols, we are doing this. If we get number like this, 3 digits and 2 digits. Now what to do? So basically we have done two kinds of multiplication techniques. One where the base is same, the base is different, but the number of digits was same. Here the number of digits is also different. In this case, we'll do just one thing, as Karthikeya also wants to do that. What to do? Anybody? Let's see how many of you are into this totally. What should we do over here? We can increase the number of digits of this number by putting a 0 over here. Now both become 3 digit. All right? This is interesting. This has got a sense of humor also. We just put a 0 over there and we manipulated the numbers according to our whims and fancies. 8 5s are 40. Then these two. 7 5s are 35 plus 8 4s are 32. That comes out to be 67. Then 3. 2 5s are 10. 8 zeros are 0. 7 4s are 28. We get 38 over here. All right. So when we put 0 over there, it will be good. 2 4s are 8 and 0. And this is 0, of course. We get 0 over here. 71. 7 goes here. 45. 4 goes here. And 12. We get 12510 as our answer. Ishan, it's not 8510. Check this. आकाश एक बार थोड़ा सा वो करना, सेशन को हल्का से रिवाइंड करना. कैसा साइन लगेगा मैंने बताया था, वो ट्रैक्टनबर्ग ट्रायंगल के टाइम पे उस स्लाइड पे देखना, आपको दिखाई दे जाएगा. 12510 is the answer. Well done. Very good. So this part is clear to almost everyone. And I kept only this much. This is not huge, but if you keep on practicing, I want you to do a homework that practice 5 questions, 5 random numbers from all these topics. And then after that, just talk to your parents, siblings, friends, and teach them this. And then tomorrow when we meet, just tell me what was their reaction. Were they shocked and surprised? So you can go to them, you can be really cool. You can act and walk cool. Just give them the calculator and tell them, okay, 103, 105, to multiply it. I'll do it, in my brain. And you'll really enjoy that. But before ending this class, I want to share a secret which was probably the caveman technique when, when back in the times prehistoric era, so people might be doing that. We'll do that and then the session will end. That's a take home. Okay. This is this is magical, and for this you don't actually, just a minute. I'm discussing this method because I want to give you an imaginative thinking that how all the branches of mathematics are connected. Okay, let's do that. One last part, one last thing. If I have to multiply 12 into 13, now I'm just trying to give you a visual insight behind the numbers, and that is how geometry came into existence. So when we'll be doing geometry later on, this is something which will increase your visualization. You don't have to cram all the formulae. So 12 and 13, an ancient technique is to write 12, they used symbols like this. One straight line, it's a straight line, but at an angle of 45 degree. And then these two straight lines representing 2. This is 1, this is 2. So basically this is 12. All right? All right? And then for 13, one line here and then 3 lines close to each other. This will be 3. Now look at this. Ancient technique. Here we have 3 planes of perception. 1, 2, and 3. All right. How many points of intersection do we have in each plane? Here we have 1, 2, 3, 4, 5, and 6 points of intersection. Here we have 1, 2, 3, 4, 5 points of intersection. Here we have only 1 point of intersection. 1, 5, 6. That is the answer. That is the answer. All right, so look at this. Now this tells us something about numbers and multiplication, that in two dimensions, product is nothing but the area, and in 3 dimensions, product is nothing but the volume, and that is why to calculate area, we multiply length and breadth, and that is why to calculate volume, we multiply length, breadth, and height. Look at this. So multiplication gives you an insight to the geometry and mensuration. And that is where I like to end the session. Keep this in mind. Keep on thinking. This will actually, a kind of brainstorming, and you will love this. Thank you. Thanks a lot. Have a great weekend. Bye-bye. See you. Thanks, everyone. Yeah, Japanese, Sumit, Japanese actually, kind of propagated it, but it was more ancient than Japanese civilization. Bye-bye, everyone. You're welcome.